Welcome back to DellyMaths Concepts. We are continuing on what we left off yesterday, solving equations. But today, we're actually looking at rational equations. If you're new to this channel, subscribe to the channel and like this video. Drop a comment. We're solving, so we're at number 1. We're solving this equation here. All right, so whenever we're solving these rational equations, we want to take a look at the denominators. And as you can see, at our denominators, we're looking at m to the second power, 3m to the second power. We want to find a term here that will be able to dissolve our denominator. We do not want any fractions. So we're going to multiply everything throughout by 3m to the second power. So for example, we're going to multiply this term, then this term, then this term by 3m to the second power. So we have 3m to the second power, and we're going to multiply that by 3 over m to the second power. That is equal to, again, we're going to multiply by 3m to the second, and this will be multiplied by m minus 4 over 3m to the second. And again, we're still multiplying. So we're multiplying everything. We're going to, as we'd say, we'll multiply throughout by 3m to the second power. Why are we doing that? We're doing that so that we could cancel all the denominators. So here, m squared would have canceled right there. 3m squared cancel fully here. 3m squared cancel fully here. So those would have canceled. What we're left with on the left side would be 3 times 3. That's going to give us the 9 right there. Remember, what we're left with here is m minus 4. So this is just m minus 4 plus, and here we're left with 2. So we have 2. So what we're going to do here now is to try to relax and just work this out. So let's just rewrite. So 9 is equal to m minus 4 plus 2. And this is basically m minus 2. And then in an effort to have the m by itself, I'm going to add 2 to both sides so that negative 2 plus 2 becomes a 0. That's what we call zero pair. So on my left side, I'm going to add 2, so I have 11. So m is actually equal to 11. So basically what we did here is to get rid of our denominators by finding a common LCM. And that LCM would have been 3m to the second power. Let's take a look at the second example here. All right, so for example 2, right? So in example 2, I realized that my denominators are as follows. I have m, I have n, I have 5n, and then 5n again. So the intention is to get rid of those denominators. I will use a term here that n can go into, as well as 5n. So that is 5n. So if I use 5n to multiply throughout, so I'm going to multiply it by 1 over n. I'm going to use 5n to multiply by 1 over 5n. And I'm going to use that same 5n to multiply by n minus 1 all over 5n. So the basic idea, I'll highlight it, right? Oh, I have 5 here. This is 5n. So the basic idea is, as you can see, I highlight. So 5n was used to multiply throughout because it is the LCM for those terms in the denominator. In so doing, n cancel n, leaving 5. So we have 5 times 1 there. This is going to give us a 5 here. 5n would have fully canceled itself. We're left with 1 times 1, which is 1. Here, 5n again would have fully canceled itself. We're left with 1 times this. So what we actually have here is a negative. And let me just write it back first. So this is what we have when we have gotten rid of the denominator. And that is the aim. Get rid of the denominator first. Let us clear this up. So I'm left with 5 here. The 1 is still here, but I'm going to distribute this negative here. This negative here will be distributed inside. Basically, it's like a negative 1. So negative 1 times n will become negative 1n. Negative 1 times negative 1 give us a positive 1. So I basically distributed that negative sign inside the bracket. Now let's see what we have. Put things together now. 5 is over there. 1 plus 1 becomes 2. So if you want to put together the integers, no problem. This is negative n. So let's just work. if I subtract 2 from both sides, basically what I'm looking at here is that I'm having 3 equal to, this becomes 0, negative n. So negative n. So in order for me to change the negative n, I'd have to multiply everything by -1. So this becomes -3, and then this becomes positive n. So n is equal to -3. So there it is for my second example. So basically the aim is that we want to get rid of the denominators by finding a LCM, and we work our way through it. Let's go to our third example. In our third example, for the denominators, what we're looking at is 3, 5, and 3x. I do need a term so that these denominators could go into. So I'm going to use 15 for the 3 and the 5, and then x be attached to it. So 15x is what is going to rescue us. So it's going to be 15x, and I'm going to multiply that by 2/3 minus 15x. Let me write my 15x proper. So I have my 15x right there. And that will be multiplied by 1/5 again. And I still have a 15x. And that is going to multiply by 7/3x. So basically, here it is that this is my LCM. My LCM is 15x, 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 right? And I'm going to use it to multiply by all the terms. So let us cancel. 3 to itself is 1, 3 into the 15. So I'm left with 5x here. 5 into itself is 1, 5 into 15 is 3, so that is 3x here. 3x into itself is 1, but 3x into 15x, that's going to leave us with 5. So we don't have any x leaving there, it cancels fully. So basically, let us just break this down. 5x times 2, I'm right here. 5x times 2, that's going to give me 10x. And this is negative 3x times 1. This is negative 3x. This is equal to 3 5s, 15. No, not 5 times 7, that's 35. All right, so let us continue working. So basically, this is 7x, and this is equal to 35. And then 7 times x is what we have. We divide both sides by 7. So you could see that x is going to equal to 7, 5, 35. So x is equal to 5 for my third example right there. All right, let us take a look at number 4. At number 4 here, what I have is 2 different denominators, an x plus 2 and an x plus 4. There are many ways to do this, but I'm just going to continue working the way I have been working. So a term that we could use for this, right, is that we could multiply throughout by x plus 2 into x plus 4. For example, x plus 2, x plus 4. That's my LCM, and we're going to use it to multiply by 3 over x plus 2. So that's on the left side. On the right side, I'm still going to have to use x plus 2 and x plus 4. So this is my LCM, and I'm using this to multiply by 5 over x plus 4. So my LCM, as you can see, would have been these 2 terms, which were from my denominator combined. Why did I do it? Because I could use it to cancel these denominators. So x plus 2 cancel x plus 2. Let me just write what we have. So basically what we have is, I could just put this in the order that I want. The 3 times x plus 4, that's left on the left side. On the right side, this x plus 4 cancel x plus 4. What I'm really left with is 5 times x plus 2. So from this, we're going to do some distribution. So I'm going to distribute the 3 inside here. Then I'm going to distribute the 5 inside there. Let's go ahead. 3 times x is going to give me 3x. 3 times 4 will give me positive 12. And this is going to equal to 5 times x, which will give me 5x. And 5 times 2 will give me 10. So with this now, we are going to try to call it like terms. So let us say I want to collect my x's on a certain side, whichever side. Let us say I want to collect my x's on the right side. So if I want to collect the x's on the right, I'm going to have to remove the 3x from the left. So I'm going to subtract 3x from both sides. So that on the left side, there is no x. I'll just have 12. And this is going to equal to 5x minus 3x will leave me with 2x plus 10. Finally, I'm going to subtract 10 from both sides so that I'm left with the x's only on the right side. Why did I subtract 10? Because what I have here is a positive 10. So a positive and a negative 10 would have been a 0 pair, and that's going to cancel out. On my left side, I'll have 2, which is equal to 2x. We're almost there. We divide both sides by 2, and then 1 is equal to x. So the response for that is that x is equal to 1 right here, and we're good, right? So that is our fourth example. Let's take a trip to the number 5. All right, so for number 5, as you can see, what we're looking at is we do have 1 over x, which is equal to 6 over 5x plus 1. LCM, we need to get rid of these denominators. So the LCM is going to be a 5 and an x combined because we want to be able to divide x into the LCM and 5x into the LCM. So I'm going to multiply throughout by 5x. I'm going to have 5x here, and we're going to use that to multiply by 1 over x. Then I'm going to use this same 5x to multiply by 6 over 5x. Also, I'm going to be using 5x again to multiply by 1. If I do highlight my LCM, here it is, 5x there, 5x there, 5x there. So it was used to multiply throughout. Let's cancel. Getting rid of the denominator is of importance when we're doing our rational equation. So x into itself is 1, cancel there. So 5 times 1 will give us a 5. How about my equal sign? On the right side, 5x will cancel itself 1 time, leaving me with 6. And then 5x times 1, there's nothing to cancel here. So 5x times 1 is just a 5x. In order to get the x's by itself, or the x, I'm going to subtract 6. Why? Because I do have a positive 6. So if I employ a subtracting 6, it's going to become a 0 pair. And then it's going to cancel itself out. In balancing, I subtract 6. I have negative 1 on the left side, which is equal to 5x. Finally, I'm going to divide both sides by 5 so that the x is alone. So you could see that negative 1/5 is equal to x. And that is my number 5. Let's do the last one. Right? So lastly, I'm going to do this. So for this one, we're observing that our denominators are as follows: 6x squared, 2x, and 6x squared. Now, I do need a term such that 6x squared and 2x can go into without a remainder. 6x squared is going to be my term. So I'm going to use 6x squared, and I'm going to use it to multiply by 1 over 6x squared. And I'm going to still use 6x squared to multiply by 1 over 2x. I'll continue by using 6x squared, and I will multiply by 7 over 6x squared. So let me highlight my LCM. It was 6x squared. And if you look, you'll see that I do use it to multiply throughout. So finally, I'm going to try to cancel so that my denominator disappears. 6x squared into itself is 1. It's going to cancel there. So 1 times 1, we're left with 1 here. There's an equal sign here. 6x squared divided by 2x, though. This is going to give me 3 with x, right? Because x to the second divided by x leave x. So this is 3x times 1, which is going to just give me 3x. 6x squared cancels itself fully here 1 time. 1 times 7 is 7. And we're almost getting there. So what I'm going to do here is to keep the x on the right, which is right here. I'm going to leave that, but I'm going to subtract the 7 because I have a positive 7. So if I subtract 7, this becomes a 0 right here. And I'm going to have to subtract 7 from the other side for balancing. So 1 subtract 7 is negative 6. And this, I'm left with 3x. Remember, this becomes 0 right there. So in order to get that x alone, I'll divide both sides by 3. So that 3 would have canceled there. I'll have negative 2 here. 6, -6 divided by 3 is -2, which is equal to x, and that's my final answer. Well, that is what it is right now for rational equation. So the conclusion is try to get rid of your denominator by finding an LCM to multiply throughout so that the denominator can be dissolved as you work along. See you next time for the next video.